Hi, this is your Professor Sudha Kolathuparambal. In this section, we will learn the chain rule. We usually use the chain rule to find the derivative of the composite function. So, if we want to find the derivative of composite function, that is f of g of x form, then we will take the derivative of the outer function. Inner function stay the same. Then multiply by the derivative of the inner function. Let me write in the simple notation form like if it is f of u where u is a function of x, then it will be f prime of u, derivative of the outer function, inner function stay the same, then we are multiplying by the derivative of the inner function. Let me explain this with an example. Let's say y equal x cube plus 4 power 5. So this whole thing like inside the parenthesis x cube plus 4, that is the inner function. So this whole thing is the inner function. And the outer function is the power function. So when we apply the rule or while taking the derivative, we will apply the power rule first. So bring the exponent in front of that and subtract 1 from the power, right? So it will be 5 and the inner function that is the same. Then multiply by the derivative of this whole thing, derivative of this inner function. Derivative of x cube is 3x square, derivative of 4 is 0. We can write our final answer in nice way. 5 times 3, 15 x square and x cube plus 4 power 4. That is the final answer. Let's do another example. Y equal 4 x cube minus 5x plus 2 power 10. So this is actually constant and a function. So when you are taking the derivative, it will be constant times the derivative of this entire function, right? But when we are taking the derivative of this function, this is a composite function, so we need to use the chain rule. If it is difficult for you to do this problem in one step, you can actually take u as x cube minus 5x plus 2, then take the derivative of that. Derivative of x cube is 3x square, derivative of negative 5x is negative 5, derivative of 2 is 0. So u prime is 3x square minus 5. So if I'm taking this inner function as u, so it will be 4u power 10. That is my question. So I'm expressing this in terms of u. Now apply the power rule and take the derivative. So constant times derivative of that function, that is 10 times u power 9, then multiply by the derivative of the inner function, that is the chain rule. So y prime is 4 times 10 u power 9 and u prime is 3x square minus 5. We already calculated u prime, so you can substitute that. You can multiply these two and replace this u with our substitution. Let's do a few more examples. Let y equal 1 plus x cube power half. So while taking the derivative, this is the inner function. So inner function stay the same and take the derivative of the outer function, the power function. So bring the exponent in front of that, subtract 1 from the power. Then multiply by the derivative of the inner function. So that will be 0, derivative of 1 is 0, derivative of x cube is 3x square. Now simplify. So y prime equal 3 over 2 x square 1 plus x cube power negative half. We can write with the positive exponent by moving this term to the denominator. That is same as writing square root of, so let me write square root of 1 plus x cube. So this is the derivative. So here first we apply the power rule. Bring the exponent in front of that, subtract 1 from the power. Inner function stay the same. Then multiply by the derivative of the inner function. Then 3x square divided by 2 and subtract this, that is negative half. Move this entire term to the denominator so that the exponent will be positive. Power half is same as square root of 1 plus x cube. Example 4. If y is 7 over 4 minus 9x power 5, find y prime. First rewrite the question by moving the term in the denominator to the numerator. So this exponent will be negative. So this is become like a constant times a function. So it will be constant times derivative of the function while taking the derivative. Since this is a composite function, this is the inner function and negative 5 is the outer function. So we will apply the power rule first, then apply the chain rule. So it will be 7 times negative 5. Inner function stay the same and subtract 1 from the power. Then multiply by the derivative of the inner function. So this is the inner function. 4 minus 9x is the inner function. Multiply by the derivative of that. So derivative of 4 is 0. Derivative of negative 9x is negative 9. Then multiply all the numbers and simplify. So we have 7 times negative 5. 4 minus 9x power negative 6. Then we have negative 9. First rewrite the question. So if we move this term to the numerator, the exponent will be negative. Then constant times derivative of this function. So apply the power rule. Bring the exponent in front of that. Subtract 1 from the power. Inner function stay the same. Then multiply by the derivative of the inner function. Then multiply this constant. And this one is power negative 6. Move that term to the denominator so that the exponent will be positive. Let's look at another example. Here, this is product of two functions. So this is f, this is g. So we need to use the product rule, f prime g plus f g prime. But while finding the f prime and g prime, we can see that f and g are composite functions. So we need to apply the chain rule while finding f prime and g prime. So we can calculate that separately, then it will be easier to substitute into this formula. F is 3x minus 5 power 4. So f prime will be 4 times. We are applying the power rule first. Inner functions stay the same. Subtract 1 from the exponent and multiply by the derivative of the inner function. So multiply by 3. And g is 7 minus x power 10. So g prime will be, apply the power rule, inner function stay the same. Then multiply by the derivative of the inner function, negative 1. Because derivative of 7 is 0, derivative of negative x is negative 1. Here derivative of 3x is 3, derivative of 5 is 0, that's why I didn't write the 0. F prime is 12 times 3x minus 5 cube. I am simplifying this. Okay, so g prime is negative 10, 7 minus x power 9. So now we can multiply f prime g. I am applying this formula. So f prime g plus f g prime. So multiply these terms. This is f prime g f g prime. We can simplify this by taking out the GCF. So first compare this 12 and negative 10. Both will have common factor 2. So 2 is a GCF. Okay. And the term both has this factor 3x minus 5. Look at the exponent. So take the one with the lowest exponent. That will be the GCF. So 3x minus 5 cube. Now look at the other factor 7 minus x. Both the term has 7 minus x. And take the one with the lowest exponent. So 7 minus x power 9. So this whole thing is the GCF. Now you can divide each term by the GCF. So divide this first term by this GCF. So you can see that this 12 divided by 2, that is 6, and this term will cancel, and this term only one of the factor will be left because this exponent is 10 and this is 9. So while dividing we will subtract the exponent. So it will be 7 minus x power 10 minus 9. 10 minus 9 is 1. If the exponent is 1, we won't write that. Then write this plus sign. Then the second term also, divide the second term. So this is the second term, divide that by the GCF. Negative 10 divided by 2, negative 5. 7 minus x power 9. These two factor will cancel. This one while dividing, 4 minus 3, that is 1. Only one of the factor will be left. Now distribute the 6, distribute this negative 5 and add or subtract the like terms. So 42 minus 6x minus 15x plus 25, that is 42 plus 25, that is 67 minus 21x, and the GCF will be still there. So write that down. So that is the derivative. Okay, let me write down. This is y prime. So y prime equal. If we are finding the derivative of product of two functions, we will use the product rule. But while finding the derivative of composite function, we will use the chain rule. Sometimes while applying the chain rule, we have to apply the quotient rule for the inner function. Or sometimes while applying the quotient rule, if the two functions on the top and bottom are composite function, then we have to use the chain rule. So for if you get a question like this, we can actually rewrite the question like a 3 plus 2x 5 minus x power half. Then we can apply the chain rule, like bring the exponent in front of that and subtract 1 from the power. Here inner functions stay the same. Inner function is 3 plus 2x divided by 5 minus x and multiply by the derivative of the inner function. Okay. So while taking the derivative of the inner function, we have to apply the quotient rule. So this is f, this is g. So f is 3 plus 2x, f prime is 2. G is 5 minus x, so g prime is negative 1. So quotient rule is f prime g minus fg prime whole divided by g square. So f prime g, fg prime whole divided by 2 square. So this one we can simplify and write 3 plus 2x, 5 minus x, negative half, and the quotient rule f prime g minus f g prime whole divided by g square. G is 5 minus x square. In order to make the exponent positive, switch the or flip the terms. So the exponent will be positive. Then distribute these numbers. So 10 minus 2x. There are two negatives here that makes it positive. So if I open the parenthesis, there won't be any change in the sign of these two terms. So that will be plus 3 plus 2x divided by 5 minus x square. Add the like terms. 13, oh, this 2x will cancel, so we have only 13 at the numerator and square. If you want, you can simplify this again, this 5 minus x, this factor and this factor. While dividing, subtract the exponent. The exponent half minus 2, that is half minus 4 divided by 2, that is negative 3 over 2. So if I move this term 5 minus x to the denominator, the exponent will be positive. Instead of negative 3 over 2 as an exponent, we will have positive 3 over 2 as the exponent. So the answer will be 13 over 2. 13 is this number and 2. And this exponent is for the numerator as well as for the denominator, right? For the numerator, we subtracted the exponent. So numerator will become 5 minus x power negative 3 over 2. Denominator we have 3 plus 2x power half. Now move this to the denominator so that it will have a positive exponent. Since both has 2 in the exponent in the denominator of the exponent, so we can rewrite this expression as square root of 5 minus x whole cube times 3 plus 2x power 1. Power 1, we don't need to write that one. So first we are rewriting the question. Apply the power rule. So bring the exponent in front of that. Subtract 1 from the power. Inner function stay the same. Then multiply by the derivative of the inner function. While taking the derivative of the inner function, we need to use the quotient rule. So this is f, this is g. So find the derivative of f and g. Then apply the quotient rule. F prime g minus fg prime whole divided by g square. Then distribute this and simplify. Here 2x will cancel and 10 plus 3, 13. While dividing, these two factors are same. So while dividing, subtract the exponent. So we got the exponent negative 3 over 2. Move this term to the denominator so that the exponent will be positive. This power has 2 in the denominator, so that is same as writing square root. And this is the exponent for each factor. So this is the final answer for the derivative of this function.